Welcome to your second lecture. In this lecture, we will talk about identification of a research problem. We want to know, where do we start research? Well, this is it. We want to identify a problem, and in doing so, we want to develop good quality research questions. We'll think about the types of research questions we can develop, the motivation behind them, focus on some of the terminology like types of variables, and then get a little bit into hypothesis testing here. This is the center of your research problem. So before we can answer really cool questions, a lot of research we think about as answering questions, we need to figure out what problems we're interested in. So you need to pick a topic area. That's your very first step. What I would say is do yourself a really big favor and be interested in your topic area. In this class, of course, you should be interested, but if you start to do things like a thesis or a publication or a dissertation, you're going to be investing a lot of your time in it. Make sure you are interested in the areas that you're doing research in. So for me, I might think of some of my past research, some academic interests, as well as personal interests, and try and pull some of those ideas together. So I'm interested in modern assessment methods and testing design. So there's new innovative ways of looking at social constructs, looking at the way that we conduct assessment in the classroom, integrate in standardized testing with classroom assessment. And all these different ideas might just begin to give me a topic area that I would look to investigate. Measurement models, I might be interested in different measurement models for assessment tools. So in my world, I might be thinking, well, I want to investigate classical test models and new innovative theory and get into the literature to try and pick a topic area in measurement models. I might also intertwine this with another area of interest. I may be interested in how models fit in statistics. So I might combine those two ideas or begin to just use those as areas to investigate, to come up with a new research topic, a new research problem. I might use a personal interest. I'm interested in games of chance. So I might narrow that down just a little bit and look up Bayesian statistics and games of chance to try and come up with something that would be an interesting research problem. I like to meditate, so maybe I might combine areas of meditation, well-being, and learning. I might try to come up with a research problem, whether or not there's an impact on different types of well-being and meditation practices with increasing our learning ability. Different types of activities maybe you're interested in. For me, I do a lot of cycling recently, some martial arts. Maybe I could put some of my personal interests and call them exercise and see if exercise impacts learning and begin to look in the field for new areas of research. I know it's early in the video, but this is a really great pause opportunity. What it would be useful for you to do is just to think up a few topics, maybe pick 3 to 5 topics in an area that interests you. That way you can think about your academic interest. Don't worry about mine. I just gave you this as a quick walkthrough of something you might think about, a way you might think about picking up some research problems. This is not the only way we would consider developing research problems, but maybe you think of 3 to 5 different research areas. Write down the topic area of interest for yourself and where you might find exposure to it besides the obvious reading literature, going to a virtual library this semester. You might think about how you might work with other colleagues. So if you just take that moment, hit the pause button, and let's come back to our video afterward. Now what I'd like you to do is take your topic areas, whether you pick 2, 3, 5, and figure a few to focus on as you go through this lecture. It's just useful to have your general research problem, your topic area of interest, at hand and maybe take some notes as you go along. So when we get into developing the research question and as we get into hypothesis testing and independent variables, dependent variables, you might take notes on ideas that you have in your topic area. So as I give an example, you might try and translate it into something you're more interested in. Einstein said if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about solutions. A well-stated question, is already partially or half answered. So we want to ask good questions. We want those questions to be relevant to the problem we're interested in, and they should be important. One of the things when I say important, it should be meaningful in the field, and also you might want to be looking at things that are gaps in the literature or new and up and coming trends. But you want to be asking good questions. In doing so, you can be talking to your professors, your mentors, other colleagues, whether it's work colleagues or other graduate students. Also consider what your research passions are, because if you are interested in the idea, again, you will more likely follow through. But also, you want to make sure that these are not just personal interests. I mean, it's good if you can do that, but make sure these are areas that are your areas that you're going to be interested in from a research perspective and that you're deeply interested in. All right, so we've discussed research problems and making sure that you're interested in your research topic area. But when it comes to really specific research questions, as we want to begin to develop research questions in that topic area, where do those emerge from? Hopefully they emerge from things you're having fun doing. But realistically, it might just be a personal interest of yours, maybe a shared interest. Maybe you have a professor or mentor that's working on a problem that you can relate to, and it might be a subset of what they're doing. Also, it might be other colleagues that you're working with, other graduate students might be working on a problem area, and you could be discussing these things. And it doesn't have to happen immediately, and it doesn't necessarily even have to be a personal interest. Sometimes we take our personal interests combined with a problem area that we're either good at or involved with already, and we look to see what agencies are looking for, funding agencies. So if we're going to be conducting funded research, for me, I may be interested in generally in testing and measurement, or maybe I'm interested in impacts on learning activities and meditation. And a funding agency comes up with something that I need to adjust my question for slightly or adjust my area for slightly. That may be an extrinsic motivation, right? I want to get funded to be conducting some research, but it's still an area of interest of mine. So we also want to be able to get exposure. So it's good to be engaged in research activities. So some of those activities you could be doing are literature reviews, whether you're doing it on your own or maybe with some colleagues. One of the assignments in this class is you're going to be producing. Part of the assignment is going to be a production of a literature review for your final paper. And it's good to work with a colleague in developing this, because you get to listen to what someone else thinks about your literature idea and you get to synthesize ideas together. Also, you might consider if there's time periods where you can find faculty working on data efforts, whether it's data collection or data analysis efforts. Those are really good ideas as you're working with someone else to begin to percolate ideas for questions in a topic area that you're interested in. These things don't typically happen overnight. So, you don't just sit down, think of a research question in your topic area overnight. A lot of times you're doing research in an area for a while, you're working with someone else, you're working with your colleagues, or you're thinking about a paper idea, and they begin to emerge. And you may start with one research question, iteratively develop that research question into something that's more interesting for you, or potentially externally that might be more fundable for an agency. Our research questions and where they come from, where your research interest. I'll just let you take a moment and read that if you want. So you've gone through and picked out a couple topic areas. In the background, you're starting to consider general research problems Don't have to happen overnight or over the course of 5 minutes of a video, but you're beginning to think about topics and ideas which you can modify and refine into good research questions. And as we look to develop other qualities of good research questions, we want to first make sure for our questions that they should be interesting, and not just interesting to us, but to some area of the professional community. In my work that I do, I have some areas, some of my topic areas are interested to a very broad educational or psychological community, whereas other areas there may be a very, very small group of my colleagues that are interested in those areas, but it is still room for that research to be conducted. So you need to make sure that your research is interesting to others as well. Make sure it's original. I mean, you can be extending an existing argument, but make sure you're conducting original research. This means conducting a review, looking at the literature, going back and forth. We'll get more into this next week, but it means finding a gap in the literature, something that hasn't been done before. We want to have significance from either a practical or theoretical view. So it could be a local problem that you're having, some sort of action research, or it could be more of a general theoretical interest to more of a larger community. Can you actually conduct research on it? You want to make sure that it's not just a philosophical issue. There's nothing wrong with investigating a philosophical question, but you want to make sure that it's an actual empirical, researchable question. And then can you actually do it? Is it feasible? Do you have the resources to conduct it? Is it ethical? You should be considering those ideas as you are developing a good quality research question. Also keep in mind the broad idea of research, that research is done generally for the purpose of explaining or predicting some phenomena. It could be specific in the operation of a school, a teaching method, a new learning method, a new assessment method. And it could be done very broad for theoretical purposes, a new model that you're looking at. But research is a process, and we want to make sure that we have a really good research questions to help support that process. Because, of note, the questions themselves that we're asking become the center of all of our research. Now, we also want to be thinking about how we might write our research questions. There's just some general guidance. We'll get into more examples in a moment. Make sure that the research question that we're thinking of is complex enough to be analyzed. We don't just want to answer it with a simple yes or no question. The goal is that it should require some sort of synthesis of ideas. Let's make sure that we are open to examination. We want our potential answers to be debatable. We don't just want it to be a certain trajectory toward the answer we're expecting, but we want to be able to debate the research question. We want to analyze the research question. It should be an arguable question. And then as we begin to write these, it's just best practice if we can be clear about a specific topic area, about a specific question or problem statement, that we remain focused, and that's narrow enough that it can be answered within a reasonable amount of space. If you have 20 pages or if you have a 100-page thesis, whatever it might be. And of course, we want to be as concise as possible when considering how we're going to write our research questions. Remember, all of this comes from doing some preliminary research on your general ideas that you're interested in. You're finding topics. You've gone through, you have some sort of problem area. Now you're building a question, and it's an iterative process. Your research problem or research questions that you're developing typically start off broad. I mean, we've started off today broad, very broad. We just have general topic areas. We begin to think about research problems and research questions. And then we're going to systematically revise these and narrow those questions to become more focused. They don't just have to be questions. It is acceptable to have a research problem statement, which is a declarative or descriptive statement. But also it's okay if we want to keep them in a question form. Sometimes question form help us to think about our ideas and what answers we might consider. indicate the focus of your research question and the context. In education, there should be some sort of educational context. In other fields, other social sciences and hard sciences, it should be within that field's context. And of course, as we narrow, as we begin to clarify and redefine our research questions, the idea is we're coming up with the right questions for our research. So it's an iterative process. We're working to become precise and definitive, but it doesn't have to start off that way. So you may write a couple questions. They might be kind of a little bit more loose, maybe some problem statements. You go read some research. You find a little new gap in the literature. You redefine your questions, or you find that the question originally asked had been answered, and it's a cycle. And then you begin discussing these potentially with colleagues, or as you begin writing, you realize you need to redraft your statement. And all of this is done before we've done the actual research. So our questions are an iterative process and part of the process of research. You can think about it as narrowing the topic, thinking of the questions, and then you're going to have a focused question. There's a lot of different ways we could categorize our research questions. We're going to generalize our research questions right now from descriptive through relational to causal. We'll start with descriptive. So in a descriptive study, when we're doing descriptive research, in general, we're just describing what exists. So there's a lot of opinion polls out there, for example, about whether somebody would vote a certain way in the election. Also, there's a lot of polling going on and surveys going on about what proportion of people would send their children back to a primary school, or perhaps at a university, what proportion of the incoming freshmen are going to defer for a year. These are all descriptive. We want to know something about the general population and how it's functioning. In a relational question, we begin to design some form of relationship between multiple variables. The type of variables could be a correlation, or it could be a comparative study. So for example, if we're thinking about parents sending their kids back to school, we could decide whether or not there's incoming freshmen, whether they're deferring for a year. We can think about this as a relationship based on whether there's public or private institute. It could be gender of child. It could be income. So it could be parental social and economic status. So we want to build a relationship between those sending their kids back to school or those opting out of the university for a year, and perhaps whether it's a public or private institute. So under relationships, we could see those relationships being with one variable and a variable that we correlate with, and we'll discuss that more. Or it could be a comparative. It could be we want to know really the difference between public and private schools and whether there's a different pattern of sending your children back. Now, when we get to a causal relationship, we're going to design a study so that we believe that one variable determines another. So it's designed so that we know that there's some sort of cause or effect of one variable on some outcome that we're interested in. If we're thinking about sending our kids back to school, during this pandemic, during the crisis, we might be thinking things like, does an increase in the virus predict whether or not people are more willing to send their children back to school, or whether someone is willing to attend the first year at a university? And we'll sort of look at this later. That might be more of the quasi-experimental, even though there's a prediction nature and a claim toward causality. It's not quite as strong because it's more observational. However, we can think about observation, we can think about true cause and effect. Typically, we think about entering in a treatment into a research study. Well, a very big treatment effect would be when a vaccine that we trust is entered into the population. How will that impact people's willingness to send their children back to school or for university or to attend the first year of your university? So these 3 questions don't have to be, they can cover many of the types of questions that we're going to have from a quantitative perspective, and they stack on each other. That's sort of why I have them this way. If you're doing the relationship, if you're looking at correlations, you're also going to be describing your research. If you're doing a causal study to try and determine some cause and effect, you're also going to be looking at relationships and describing that research. So they build on each other. And of these, you can kind of think of them also as how much effort typically goes in a descriptive study. When we get in descriptive research, we're typically just need to describe what occurred. In relational research, whether it's correlational or comparative, we have to be able to make, or sort of building a little bit more complex model. And then in causal relationship, there's a lot more effort that has to occur from the researcher. All right, hopefully you're ready to have some research fun. Well, I'll call it fun, you don't have to. So what I'd like you to do is, if you're doing the follow along with your topic ideas, this is a great opportunity to look at the questions you've been thinking about, the problems you've been thinking about, the topics that you have, pick a few of them and follow along with the types of research questions and examples and create your own. So descriptive research questions, the goal is that we're going to describe the variable we're measuring. A purpose is to quantify variables of interest. You can think about this as what is going on, what exists. So here's some examples. What is the prevalence of subjective well-being at George Washington University? So we're not asking a relational question. We just want to know, what is the prevalence? So we may have different categories of well-being. We may ask a poll or a questionnaire, and we just want the answer to our quantitative variable to be able to describe it. How do primary school teachers spend their time during the pandemic? We're not even making any judgment here. We just want to be able to describe those quantities. How do parents feel about online schooling? How do we gain and maintain our subjective well-being across cultures and continents? So this one's interesting. This one may need a little refining, depending on what you want to do, what your real goals are. If you're just looking to quantify those areas, even though there's multiple variables in there, and you're not doing necessarily a comparison, and you're just describing, that's okay. But we might be seeing this, even though it's descriptive, this may start to slip into a comparative research question, so we might refine it. So hopefully that's a good example for you as you start to think about more meaningful research questions. And here's another example. What are the characteristics of self-actualized persons? So the idea here is that these are just good starting point research questions. I wrote them all as questions as opposed to as statements, but you can see that these all are attempting to get at something we want to quantify. We want to know what's going on, what are the state of things. This is your pause opportunity, and we'll do that at the end of each of these. You can take a pause if I went too fast, or you just want to sit there and think about how you might build a descriptive research question for yourself. We've written some descriptive research questions. You can either create new correlational questions, relationship questions, comparison questions, or you can just build on something you've already written. These questions, when it's correlational, when they're relationships we care about, we want to know whether or to what degree our relationships exist amongst variables. It could be 2 or more variables. I'll note this here, as everybody's probably heard before, of some nature, that correlation doesn't mean causation, which means it's a predictive model. We're not necessarily making a causal claim here. We want to look at the relationships is our intention amongst variables. So let's look at some examples. We might want to know what is the relationship between intelligence and well-being. We also might want to know what are the relationships amongst perceived happiness, life satisfaction, well-being, and mindfulness. So there's multiple things we want to know the relationships of. And we might even start to write this in a predictive sense. What is the connection between learning a task and the knowledge associated with that task? And then finally, Is there any pattern to occurrence of earthquakes? These are all written intentionally as correlational, even though we might start to think about what type of prediction we might want to apply here. What type of causation we might even have intuitions about. Again, this is a pause moment, so I'll let pause here and try out some of these on your own. Well, I don't take credit for these graphs or the cartoon, but I thought they were kind of funny ways of segueing into our causation questions. I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like that class helped. Well, maybe. And the relationship between mozzarella cheese and engineering doctoral awards is pretty amusing. But that's a real set of data. So that's interesting, right? This is just a spurious relationship, just a relationship that just arises that you might make something out of that there's nothing to be made out of there. You've gone through and we've looked at descriptive questions, research questions, sort of the most basic types of research questions we'll develop. Got a little bit more interesting when we started thinking about correlations and even began to think about how those correlations might be directional in the sense of a prediction. And now we're going to take a little stronger stance in experimental style questions. These are going to be questions which are designed to investigate a cause and effect relationship. So we can think about it, we actually want to create the explanation. Here are some examples. What is the effect of exercise on heart rate? How does martial arts training affect the rate of carbon dioxide production? What is the effect of self-paced instruction on student well-being? That one might be important to you. May be important now currently in the U.S. where there's so many students going back to school, both with synchronous and asynchronous learning. What effect does positive reinforcement have on students' attitudes towards school? And what effect does a task analysis have on training effects? And the idea here is that I can design my research to be causal. That is, I want to actually have some sort of treatment impact here. And for example, a treatment impact for what effect is the self-paced instruction on student well-being? I may have self-paced and non-self-paced instruction for students and see if there's actually a treatment impact. Now the question here will be if it's truly experimental or if it's quasi-experimental, and I'll get to those research questions in one moment. First, this is your pause opportunity. You might want to restructure some of your questions more in the form that you could determine a causal impact. This is just a brief introduction to cause and effect. We're going to get more into experimental design in a few chapters and true experiments. This is the idea of a true experimentation. We want to be able to establish cause and effect. How does something work is important to know, or maybe why is something there. When we say cause and effect, we really are talking about a relationship between two things, two phenomena, where one is the reason for the other being. And we want a lot of compelling evidence here. And just to note, one cause could have multiple effects. We could introduce a causal treatment and a lot of things could happen. So first, we want to be able to establish between two things, like an independent or dependent variable, which we'll get to in a moment. So just think about establishing between two variables that there's a relationship. So we start off by saying there's an association, there's a relationship between variable 1 and variable 2. Next, order matters. Right? We need to be able to establish that there's a relationship such that there's an order. Here's a little silly cartoon where the mice are hitting the switch and observing the experimenter. So order matters when we start to think about causal relationships and the claims we would like to make. And also, there's this idea of what we call non-spuriousness. That's a fancy way of saying something's not false. So a spurious relationship is not being what it's purported to be. Basically, it's a false or fake relation or claim. So non-spuriousness is leaning toward the truth. But the idea here is that we're trying to remove any spurious relations, any spurious relationships that might be there. So what is an example of this? So I found a little example here that there's a correlation between eating ice cream and criminal activity, or you sometimes hear this as cracks in the sidewalk and truancy in courses. So there's a relationship. The correlation here between people eating ice cream and crimes being committed is an association. But that relationship can be fully explained by summer activities as heat increases, as the summer occurs, the sun is shining and it's daylight. There are both people increased activity of eating ice cream and increased activity of criminal activity. So interesting here that relationship exists, but there's a causal reason why there's a relationship there. So one should be very, very cautious when trying to make any sort of claim. We wouldn't want to try to make a causal relationship that people eat ice cream and then go commit crimes. So as we focus on research questions, we've gone from our descriptive questions, our correlational questions, and our experimental questions. And remember, this is all focused on the research questions themselves. But we have another type. This seems to be sort of taking a step back. In reality, this is where many of you will find yourselves more in correlational and quasi-experimental structures. You'll have relationships that exist, and you want to demonstrate that there's some cause and effect. So you'll move toward a research question and an experiment design that is somewhat experimental. We call this quasi-experimental, and we will come back to this in a chapter later on in our lectures. Questions are designed here to investigate cause and effect relationships, but we have already intact groups. So think about students in the classroom. They're intact groups. We're not going to change those groups. We can set up a structure that looks like a cause and effect relationship, but we didn't get to control who was in which group. So control is really the main element between experimental and quasi-experimental designs. So examples here. What is the effect of gender on science achievement? What effect does a positive mindset have on academic success during the pandemic? How do wind farms affect the abundance of pelagic fish? Those are fish that don't swim, that sort of swim in the middle. What is the effect of exercise on classroom performance? So these are just some examples. They should look very similar to the experimental examples, but in some ways we don't get to control, if we don't get to control some of the groupings that are created for treatment and control groups or some relationship there, then it's more of a quasi-experimental design. Again, we'll come back to these ideas again. We're writing research questions and problem statements. Ideally, these things are concise and identify things, the factors or variables we're interested in. So we're just going to take a moment and get into some of the research terminology to help us understand the development of our research questions and eventually hypothesis questions that we're going to write. You'll hear the term constant. This is a characteristic or condition that is the same for all participants in your study. Let's think if we were to design an experiment that was going to look at all of incoming graduate students at the university at George Washington. All incoming graduate students would be a constant. So whether it's graduate students or undergraduates, that would be a constant in your experiment if we were looking at all freshmen at a university. And that would be my population of interest as well. Variables are going to be characteristics that take on different values or conditions for each participant. So we might think things like simple as height and weight can take on different values, test scores, mathematical ability. If you have we do a measure for an optimistic mindset, gender, what school you attend, or obviously if you're all here, then that's all a constant, but it might not, if we open it up to other schools, then it becomes a variable. Ethnicity, grade that someone is in, and if we are examining K through 12 students, their age. So these are characteristics about persons we might be interested in. There are a lot of ways to classify variables. We started off distinguishing between a constant and a variable. In research questions, research designs, we need to be able to distinguish between independent and dependent variables. Dependent variables, often abbreviated DV, sometimes you see these in equations as Y's, are our outcomes. They're the things we predicted in our model, in our equation, in our research question. An independent variable, abbreviated IV here, are things we might manipulate or classify or predict, or something we have control over. So here's a research question. What effect does positive reinforcement have on students' math achievement score? So a good practice, and we'll have a bunch of examples coming up, is to be able to distinguish between the independent and dependent variable. So we have an independent variable, IV, which is going to be the predictor. This directional area shows that we're going from the IV to a dependent variable. So I'll give you kind of a quasi-pause moment here if you want to try to do which one is the independent variable and which one is the dependent variable first. Go ahead and pause the video. What do we have control over is really the question. Well, a student really, maybe they're in classrooms, in tech rooms. Maybe we have two groups. One receives a special positive reinforcement treatment. The other one receives some sort of just normal, we could call it a placebo effect, but there's no additional treatment that's added into that group. We have control over the positive reinforcement, but we do not have control over their actual direct control over their math achievement. So we have an independent variable. When I say control here, I mean we can manipulate the positive reinforcement in each classroom. One classroom, the simplest case, one classroom receives positive reinforcement and the other one doesn't. And then we can see whether or not there was an impact on the dependent variable of mathematical achievement. Another distinction I just kind of draw here, since I bring up the categorization issue, is that numerical variables can be categorical or continuous. We're going to talk a lot more about this later in measurement topics, about things like qualitative and quantitative variables and categories and continuous measures. There's a lot of language we can put around independent variables. When we have control over the independent variable, when the researcher can change the amount of kind or presence and absence of that variable that they wish to control, that they can manipulate, we call it a manipulated independent variable. When we can't control it, but those groups exist and we can identify and classify them, we call that a classifying independent variable. Sometimes this is the distinction, whether or not we can control what we're interested in as a treatment effect between experimental and quasi-experimental designs. A control variable accounts for additional variation in our outcome. So we incorporate it into our design or our model. So you can think of our outcome as from before as mathematical achievement. Prior achievement is going to be predictive of achievement later on. So we might want to have some sort of pretest as a control variable in our model. A moderator variable. These things affect the direction or strength of the relationship between independent variables and dependent variables. They can be qualitative like sex, class, or race, or they can be qualitative like levels of achievement. And finally, confounding variables. These are just like our controlling variables, except they're not built into the research design, which makes it really difficult to untangle them. They are linked. They are the explanation of cause and effect can't be disentangled with the confound. So if we were looking at achievement scores after the fact, and we didn't look at achievement prior, depending on our design, it might be very difficult or impossible to disentangle that from prior achievement. There's a lot of language we can put around independent variables. When we have control over the independent variable, when the researcher can change the amount of kind or presence and absence of that variable that they wish to control, that they can manipulate, we call it a manipulated independent variable. When we can't control it, but those groups exist and we can identify and classify them, we call that a classifying independent variable. Sometimes this is the distinction whether or not we can control what we're interested in as a treatment effect between experimental and quasi-experimental designs. A control variable accounts for additional variation in our outcome, but we incorporate it into our design or our model. So you can think of our outcome from before as mathematical achievement. Prior achievement is going to be predictive of achievement later on. So we might want to have some sort of pretest as a control variable in our model. A moderator variable. These things affect the direction or strength of the relationship between independent variables and dependent variables. They can be qualitative like sex, class, or race, or they can be qualitative like levels of achievement. And finally, confounding variables. These are just like our controlling variables, except they're not built into the research design, which makes it really difficult to untangle them. They are linked. They are the explanation of cause and effect can't be disentangled with the confound. So if we were looking at achievement scores after the fact, and we didn't look at achievement prior, depending on our design, it might be very difficult or impossible to disentangle that from prior achievement. Later on in our textbook, we'll see the idea of an experimental variable. It's effectively the same thing as a manipulated variable. It's the way we discuss this in experimental design. Often in research and statistics and philosophy, you hear something called by another name and it means the same thing, and that's just the case. If you hear experimental variable, it just means that the researcher has a specific type of control manipulating it, and we'll look at treatment and control effects later on in the semester. You also may hear the word extraneous variable instead of confound. They mean the same thing. And then the idea of a mediator variable or intervening variable, you will sometimes hear that called similar in some ways to a moderating variable, but instead it's a theoretical variable that's actually used in a causal way to explain the link between the independent variable and dependent variable. And we may get into this later on in our statistical analyses. Operational definitions are critical to what we do in education and other social science fields. We're not able to usually directly observe the variables we're interested in. Like we don't directly observe mathematical ability, intelligence, reading achievement. They're not necessarily directly observable, so we create these manifest variables or operational definitions. So we're going to specify how a variable is going to be measured. This defines the generalizability often of our study. It's an issue of external validity. Who will it extend toward? And of course, success or failure of a study often is determined by how well these variables can be operationalized. We, the researchers, define or make up the conditions necessary to identify the variable. In a simple, maybe a little silly example, as a graduate student, I was conducting a small experiment with some friends, and we would observe a soda machine that did not return a soda, and people would get angry with this machine. So we decided to come up with a simple operational definition of someone had to contact the machine. People would often push the button a bunch of times. They would stand there and maybe even shake the machine. So we observed this, and a few things happened that we realized our operational definition was certainly not perfect. Sometimes somebody would stomp around a little bit or put their hands on their hips. And one time we observed someone just stand there and stare for a very long period of time. And after someone would put the money in the machine and not get their soda, we would stop them because we knew that you could get your money back at the front desk downstairs. And we also would ask them if they would be willing to respond to a couple questions. And one of the questions we asked this person was, how come they stood there? And they told us that they were very upset. And that was for them to stand there that long was actually a very aggressive thing, even though they didn't do anything. So for us, we would not have captured that as part of our aggression. So after we observed these things, we started to modify what we had as our operational definition for our discussion section, obviously. But it was a very interesting thing for us to see the reactions of people and eventually modify our operational definition. In coming up with operational definitions, we can begin to think about different types of operational definitions. So we could construct them in terms of how a particular object or thing operates. So for example, motivation. We might see persistent attendance of students in school as measured by number of days attended. They could be constructed in terms of what an object or phenomenon looks like. Could be this idea of team teaching. If I just say team teaching, might mean a whole bunch of different things to folks. So we could say it is utilization of 2 or more teachers to develop lesson plans and teach in 1 or more subject areas for a fixed set of students. By creating these definitions, we are eliminating other ideas people might have, but also very much specifying what we mean. Another type of operational definition might be constructed in terms of operations performed to cause the phenomenon to occur. So we might think about this idea of conflict. So we can think about it as a state produced by placing 2 or more individuals in a situation where each has the same goal, but only one can obtain it. You may think of conflict differently, but as long as we define it like this for our research, we have an operational definition. So often we have to be a little creative when coming up with operational definitions, but what I will say is a really big caution here. If in the field there are accepted practices for operational definitions, so you go to read the literature and everyone is using a term like conflict in the same way in your field, you should also use it that way as well. Otherwise, you could cause a lot of unintended misinformation out there. So if definitions or variables are used in a specific way, it's just best to use them that way. And if you want to create something new, you might just want to name it or adjust the naming convention somehow. When determining things about operational definitions as you write your research questions, I'll come back to these ideas again later on in the semester, but we may have this when we get into measurement issues. The idea of manifest variable. These are things that we can directly measure. You can think about them as concrete variables. They could be an independent or dependent variable. Then there's also this idea of these unseen factors, these constructs or factors that are latent or unseen. We can't directly measure them. They're abstract ideas. They could also be, though, independent or dependent variables. So this is really where our operational definitions are critical. So I just have my son finishing up eating some ice cream. Perhaps I want to try and define happiness, and I may use some features here to operationally define what happiness is. So even though there's some indicators of happiness, the idea, the construct, the factor of happiness is not directly observable. It's an abstract idea that I have to put operational definitions around. Now that we have some tools behind us, like some questions we'd like to answer, research questions, and we have some of the terminology with us, we're going to investigate a little bit about the research hypothesis. A research hypothesis is a specific, clear, and testable statement about a conceivable outcome of a research study, and we usually have a targeted population that we're interested in. Wiersma define this as a conjecture or proposition about the solution to a problem, the relationship of two or more variables, or the nature of some phenomena. They kind of offhand mention in here that this is the classic, we hear some sort of, it's a first guess. And I'd like to steer away from it just being a guess. It's much more of, we have reasoning to believe that we can test a hypothesis. The purpose is that we're going to provide more specific and direction to our research questions. So these are often shorter than our research questions and more specific than our general research questions. Types of research hypotheses, we have substantive research hypothesis and statistical research hypothesis. So where do these come from? I mean, these are usually coming from theory. They're coming from our research ideas, our research problems, the questions we're writing. We write out a research question, and we can begin to form it into a testable form as a research hypothesis. Typically, in identifying this, we could be looking at either prior studies or prior information, evidence, or data collection. And it's not all research have these really well-structured testable hypotheses, but in most cases, when there's exploratory research, which will, or some of our descriptive studies may not have a really well-structured or structured research hypothesis. But as we get into experimental and relationships, we're building those relationships into research, testable research hypotheses. So when thinking about the two types here with substantive research hypothesis and statistical research hypothesis, we start with our substantive hypothesis, our research hypothesis, and we have a tentative statement that indicates the direction of our results. Although if we can still have hypotheses in our exploratory studies, that we just wouldn't have a direction to our results. Often these are being informed by our theory or previous research, and hopefully we've been building our research problem around theory and previous research as well. Our statistical hypotheses we're going to be using to analyze our data. It's going to be discussed in quantitative terms, and it will help us provide direction for our methods and design of an experiment. So our statistical hypotheses are stated in statistical terms. A statistical term might be a parameter. That's a measure of the population. So if we have a average mathematical ability score, and we know that in the population that we're interested in, people tend to score 70 out of 100 possible points, that would be their average score, and that's a parameter in the population. We're going to place our statistical hypotheses in a testable form. There's always null hypothesis and alternative hypothesis. This should cover all possibilities, and they should be what's called mutually exclusive and exhaustive. Again, we'll come back to some of these ideas again when we get into inferential statistics. But that means that mutually exclusive means they don't overlap, and that they're completely exhaustive means they cover all possibilities. So I always link myself to the alternative hypothesis. Most of the time, the research question I'm interested in is related to the alternative hypothesis. The null hypothesis is kind of the hypothesis of no difference. So if in the population, on average, people are scoring a value of 70 on tests, and I have a group that I'm interested in, a sample, a subgroup of that population I'm interested in, and I give them some sort of treatment effect, maybe some sort of education or training, then I might think that they would be different than the general population. If I give a direction of that difference, we have a directional hypothesis. If I give no direction, I just say they're going to be different than the rest of the population, then we have a non-directional hypothesis. We're going to go through some examples in a moment. I just want to emphasize the directional and non-directional with null hypothesis and alternative hypothesis. The null hypothesis, the hypothesis of no difference. For a non-directional hypothesis, if we're looking at two groups as treatment groups, so we have one training methodology and a second training methodology. And in our null hypothesis, when we begin to write them, we're going to say something about that there's no difference between the two treatment effects, or there's no difference between a treatment and a control group. So that's why I sort of look at the null hypothesis as the hypothesis of no difference. That means that our research experiment really wasn't impactful. Whereas the alternative hypothesis in a non-directional hypothesis says there was some difference. It doesn't say whether something's greater than the other. It just says no difference. Whereas in a directional alternative hypothesis, the alternative hypothesis will state a difference. We might say that method 1 of training is better than method 2. But now the null hypothesis will always be all other possibilities. So in a non-directional hypothesis, the null hypothesis simply states that there's no difference between the effect we're interested in. Whereas the alternative hypothesis in the non-directional says there is some difference. Whereas in a directional hypothesis, the alternative hypothesis is going to say usually a statement about greater or less than, and the null hypothesis will always be all other conditions. Often students ask if it matters whether they have a directional or non-directional hypothesis, and the answer is it depends. If you have good evidence to suggest a direction, then you should have a directional hypothesis. If not, then maybe a non-directional hypothesis is better, because things that we expect to happen, sometimes the very opposite happens. Suppose that I'm trying to increase mathematical achievement, and I have a typical way people teach a lecture, and I create an alternative version of that, or alternative model, an alternative treatment. So I have treatment A, which is established, and treatment B, which is new. And I really think that treatment B is going to be better. And I find out, so I write my hypothesis, my alternative hypothesis, that way, in that direction. And I actually find out not only is there no difference, but there's a performance, it actually performed much worse than expected. That's meaningful, but in the opposite direction that I hoped. So unless you have a reason, usually we want a reason to have a directional hypothesis. When we're writing some of our hypotheses, you'll often more formally in classes and lectures, we'll talk about alternative and null hypotheses. Often we'll see that the alternative hypothesis, if a hypothesis is stated in someone's research, it's really the alternative. But let's just take a look here at the alternative and null. I'm going to start with the null hypothesis. The null hypothesis, as an example here, is there is no difference between the mathematical achievement scores for 8th grade students in private or public schools. Whereas the alternative hypothesis, really that hypothesis that might be driving the research, is that I may state there is a difference between the mathematical achievement scores for 8th grade students in private or versus public schools. Just as a reminder, as we kind of move on through our entire process, we're dealing mostly here with quantitative research. When we start getting into statistical and traditional hypothesis testing, part of the reason we're doing that is because it helps keep us objective. We should be doing these at the beginning of a study. We want minimal modification, and any modification to our hypotheses really should be transparent. So we're taking this example right from our textbook. It's example 2.2. Perhaps someone went through and they thought about their research area. They're interested in reading achievement in general, and they know that there's a couple programs out there. So they come up with this idea of how do reading programs affect achievement? A problem statement could be written as a study of the effect of 2 reading programs, A and B, on the reading achievement of 3rd grade students in school A. So you could modify this, obviously, as you're doing research. Maybe they're using 3rd graders because it's an available sample, but it could be, you could alter some of this as well. But our general problem statement here is very specific. It gives us a lot of information about the research that we're going to do. A hypothesis that we could state here is for students scoring in the lower 30% on prior reading achievement, those taught by program A will have a greater mean gain than those taught by program B. This is a hypothesis, and this would really be, because this is the interesting hypothesis, this is what would be linked to our alternative hypothesis. The null hypothesis would state something about no difference. As I said before, often it's just our alternative hypothesis that's stated in a journal article. Sometimes you see more formally a statistical hypothesis of null and alternative. So another hypothesis could be students who receive a greater number of program sessions, regardless of prior reading achievement, will have a greater mean in reading achievement. So we could form from our topic area, from the preliminary questions we're starting to write, from a very specific problem statement, we still can derive multiple hypotheses that we're interested in testing. What's interesting here is we should be able to pick out a couple of the types of variables that we're interested in here. And as we'll go through, I'll do a couple other examples as well. So let's think about, in general, things we'd have to operationally define. Individuals included in the study, in this case, is just third graders. We have program A and B. We should be defining those. In your book, we have the set of reading materials purchased from publisher Y and its suggested activities. And that would be program A, and program B would be the set of materials purchased from a different publisher, publisher Z, and its suggested activities. So now we have two different programs and materials to compare. The independent variables, we have reading program A and B. We can control those. If we wanted to, we could change our study by going to a different publisher or coming up with a different set of materials. We can manipulate, we can control that independent variable. The dependent variables are outcome. We're interested here on some sort of gain score in reading achievement. Some of the possible moderator variables, things that could impact the study that we might need to consider, are teachers themselves, teaching style, learning style, and student scholastic ability. Possible other variables that we might consider controlling here are prying reader achievement and gender of the student. We examine the difference between those two hypotheses. The stronger statement is the statement about students who receive a greater number of program sessions. So here specifically, all of that information I gave you about all of the possibility, when we look at this hypothesis, we know that we have some sort of control, or we have a prior reading achievement. We have the same dependent variable, some sort of gain score in reading achievement. The independent variable of reading program, also we have the number of sessions. That could be a additional variable in our model as an independent variable. And then, although it's not explicit, we could be controlling and using a moderator of different teaching styles. If we track teaching style, it strengthens our overall research design. So moderators sometimes trip people up, so we'll just go over an example of moderator variable in a research question. I'll make it, I think, relatively obvious, the moderator, by separating it out. What is the effect of popular music on elementary school children's appreciation of poetry? Is there a gender difference? We could have written this all as one question. The independent variable is the use of popular music. So we as researchers could control the type of music we're introducing. We may have just a simple popular music versus no music. We may have popular music versus other types of music. As a dependent variable, we're really interested in is appreciation of poetry. Can we change appreciation of poetry based on the type of music a child is listening to? And then, is there a gender difference here between boys and girls and boys in our population? There may be that in one self-identified gender is not different, whereas in another there is a difference. So we're using that as a moderator variable, so we can explore that. If we don't model that into our study, we wouldn't be able to tell that to be the case. So let's go ahead and try out understanding some moderator variables again. We're going to identify those moderator variables in each of these research hypotheses. Studying Shakespeare leads to an increased appreciation of Western culture among college-bound students, but not among non-college-bound students. Second hypothesis we have, different hypothesis, different topic. Behavioral modification will reduce creative behavior among elementary school children in middle class schools, but will increase creative behavior in lower middle class schools. And then when we're done this, we want to be able to, let's kind of try and link back. How might you want to phrase this as a research question that corresponds to the above research hypothesis? So, not surprisingly, this is our pause moment here. So let's take a moment, pause the video, and let's try and pick out the moderator variable in each of those two questions. And let's try and develop a research question that you might have phrased around these topic areas. Welcome back if you took a pause moment. So in our first hypothesis, the moderator variable, what is moderating this hypothesis is whether you are college bound versus non-college bound. In our second research question, it's social class of the school. And we see that there's different outcomes depending on which class you're in or whether you're college bound or not college bound. So just as an example, you may have done something a little different yourself for a research question. We might be asking questions for our first hypothesis is, what effect does studying Shakespeare have on students' appreciation of culture? As a sub-question, is there a difference between college-bound and non-college-bound status? So we may have written those questions out, as we're thinking about writing these hypothesis statements. For our second hypothesis, you may have written out, what effect does behavioral modification have on elementary school children's creative behavior? Then we could add the addition of the moderator. Is there a difference by the economic status of the school? Now let's go and we're going to walk through some research questions and statistical hypotheses, so we'll see how we develop through the process. So we start off with a research question. What is the impact of gender on students' reading comprehension scores at the end of first grade? So that's the question that we're asking. The research hypothesis is that girls will achieve higher reading comprehensive test scores than boys at the end of first grade. So we've gone from our general question, now we have a hypothesis, and it's directional. In doing so, we're going to build a statistical hypothesis. The null hypothesis is there is no difference in the mean scores on reading comprehensive tests for girls and boys. Alternatively, girl mean scores on the test will be significantly higher than boys. Technically, in the null hypothesis of no difference, if the boys score higher, that's still incorporated in the null here. It has to cover all possibilities that are not covered in the alternative. So because we believe girls are going to score higher, even if boys score higher, it's still in that category of no difference in the statistical hypothesis. Alternatively, we could have built this as a no difference hypothesis. We just say there was a difference between scores as the alternative. The variables that we're interested in is gender, boys and girls, in this case. And dependent variable is we care about the reading comprehension scores. From a research hypothesis perspective in developing statistical hypotheses, this was as straightforward as it gets. We have one independent variable and one dependent variable. And the independent variable in this particular instance only has two categories. But also as the researcher, we're not manipulating the independent variable. So that is a classification variable. But that doesn't necessarily mean some of the issues that dive into areas around the variable aren't meaningful. You have to determine what you are measuring when you measure gender identity. You need to make determinations. Is this self-selection? If so, make sure that's transparent and that's stated. Are these the only two categories someone could pick from if it's a child? Or was it the parent identifying? You need to make sure that that is well operationalized and consider the impacts in your research. Let's turn to a little bit more complicated question, research question, What is the effect of popular music on elementary school children's appreciation of poetry, and is there a gender difference? So we still have gender difference in there, but now it seems to take a different placeholder. We saw this example earlier, so you probably have recollection of this question. The hypothesis that we might draw from this now is the use of popular music will increase the appreciation of poetry among elementary school children, and that this impact will be greater for boys than among girls. Our statistical hypothesis, the null, is there's no difference in children's appreciation of poetry, and the alternative here is boys' mean scores on appreciation of poetry will be significantly greater than girls' mean scores. The variables, independent variables, use of popular music, dependent variables, appreciation of poetry, and the moderator variable is gender of girls and boys. Let's do one more example. Our research question here is, what is the effect of teacher training on teachers' rating of job satisfaction? We also have another sub-question here. Is there a difference by overall rating of life satisfaction? The hypothesis, the research hypothesis that we draw from this question, teachers who are trained in a traditional teacher education program will differ in job satisfaction than teachers who are trained in the alternative program. The statistical hypothesis here is there is no difference in ratings of job satisfaction, whereas the alternative is there is a difference in rating of job satisfaction. Now I'll give you the independent and dependent variable for this specific research hypothesis. The independent variable was type of teacher education program, traditional versus non-traditional, and we had dependent variable of job satisfaction. But that second research question that we asked, is there a difference by overall rating of life satisfaction? We could also take this research hypothesis and incorporate the idea that there's going to be a difference between those that are a standard deviation above the mean and below the mean. That is, on overall life satisfaction, could moderate what these outcomes look like. So we'd have to go back and change a little bit of our research hypothesis to incorporate our moderator and have that it could be different for those above overall life, for those a standard deviation above the mean for overall life satisfaction, or those standard deviation below the mean. So we're going to get a chance to try some of these out ourselves. How would you state a directional and a non-directional statistical hypothesis for each following research question? So the research question we'll examine is, what is the relationship between maturational status of adolescent boys and their self-concept? Remember, for each of the directional and non-directional statistical hypotheses, there's going to be a null and alternative hypothesis. You can go back and review that if you want to take your time here. This is another pause opportunity, of course, and then I'll go over some examples of what a directional and non-directional statistical hypothesis will look like. If you took the time to pause, yours might look a little different, but here's an example of a directional, null, and alternative hypothesis. The null is there is not difference in boys' self-concept by maturational status, whereas the alternative might say more mature boys will have higher self-concepts than less mature boys. A non-directional hypothesis, the null hypothesis, is maturation status does not have an effect on boys' self-concept, and the alternative hypothesis will simply state maturation status has an effect on boys' self-concept. With this example, as well with many of the others, there's a really simple structure here I'm using to write some of these questions. And that structure is simply, what is the relationship effect of independent variable on dependent variable? So kind of as a rubric, as you're just getting started and you're looking to write questions about the relationships, this is really the structure that one could use. You can be much more creative, but that's what I'm using in this case. Is what is the relationship between independent variable of maturational status of adolescent boys on dependent variable their self-concepts. We've gone through a process of developing research questions. We've thought about from the topics all the way through to some of our testable hypotheses. We just want to make sure that we're asking ourselves some questions as we're developing our research questions along the way. Does the question deal with a topic or issue that I'm interested in? And the reason I bring it up here is because we could develop a problem, come up with a research question, begin to develop a hypothesis, and realize now that that hypothesis is not something I'm interested in, or it's not significant. So throughout the whole process, we want to be thinking about some of these questions. Will the findings be considered significant? Will they be meaningful or important? Will it contribute to the field that we're interested in? Is the question researchable? Can I actually do it? Can the information be collected to answer the question? And do I have the ability, do I have the skills and expertise needed to access the information necessary? Will I be able to get done with this in a reasonable time period, especially if it's for a course, or if it's for a dissertation, or if you have a time period or in a publication? Is it doable in that reasonable time constraint? And also, don't forget ethical issues. Are there potential ethical problems in collecting your data? Is the scope of the question too narrow or too broad? We need to make sure to define our terms, operational definitions. Are there assumptions that we haven't explored? So we need to consider the question, make sure that we go through all of the quality indicators that we talked about earlier. Also consider what sources of information you might need to answer those questions. That could be things like books and journals. Most of us are using internet resources, but also think about persons that you might need to assist you in your when you consider the research question. In a face-to-face lecture, we would take some time, break up in the groups, and have some group discussion about research questions. We'll give you an opportunity to do this on Blackboard in one of the discussion boards, if you so choose. You can obviously have the opportunity to do lecture sum-ups and other things as well this week. But if you could discuss your general research interest in a post, and then along with that, try to identify 2 questions you might consider exploring. And try to keep in mind the things we've learned through this lecture about things being interesting, significant, feasible, all of the qualities of our research questions. If you want, you can move into development of statistical hypotheses, the null and alternative. You can lay it out as topic, research question, hypothesis, statistical question if you choose. And then also try to share what you might hope to learn from the 2 questions that you picked. In this lecture, we started off thinking about problem statements, research problems. How we might identify research problems, come up with good research questions, or maybe we consider this statement of a problem, and eventually develop those into hypotheses. We also went over some research terminology, things like variables and constants, different types of independent variables and the dependent variable. We made sure to go over operational definitions so that we know that any terminology that's going to be in our hypothesis, we need to make sure that we can measure the variables that we're interested in. Our hypothesis statements might not be the ends unto themselves. That is, research is a process, but they are very useful. However, sometimes we'll see in reports and journal articles that we read, we don't see an explicit statement of hypothesis. Sometimes this is intentional. Sometimes it's just the style of an individual. But whenever possible, we should be stating research hypotheses as concisely as we can and use those as the basis for our research.